Hello everyone, today we're going to talk about analyzing data using three types of functions that you're familiar with. We're going to talk about the linear function, quadratic, which creates the parabola, and then the exponential growth and decay functions. Here we have three rows of information. On the top we have functions like you see in your calculator when you type into y equals and you hit graph. On the bottom we call those scatter plots. This is data that has been gathered through real world scenarios and situations, and you can see trends occurring. Let's go ahead and match the graphs on the top row with the words, the descriptive words in the middle section. Starting with the exponential decay, if we look, we know this one's going to go start in the top and go to the right and down. So that'll be the far right graph. The quadratic positive is a parabola that opens up, so that's that one. And then we're going to do quadratic negative, meaning the parabola is opening downward. Then we have linear positive, that's the line that's going in a positive slope. That'll be our first graph. Then we have our linear negative, so the line with the negative slope, and then exponential growth, our last one going to the right and up. All right, so we're fixing to match the graphs on the bottom, our scatter plots, with what we put on the top. But before I do that, I just want to talk to you a little bit about what all this means. Looking at the bottom of the screen, you can see scatter plots. This is just a sampling of real world data that happens to trend in a familiar pattern. The statisticians and mathematicians out there use these patterns as a guide to create lines of best fit. Real world information and data is not clean or pretty. It is sloppy and messy, and we're trying to make it fit into something that looks more familiar to us to help us better understand what's going on in the real world and to help us make predictions. Okay, so let's go ahead and match up these scatter plots with something that does look familiar. Like I mentioned before, the first scatter plot on the bottom left, it makes the U shape. It's an opening up, so I'm going to say that would be quadratic positive. Then the next one, it looks the trend or the pattern is going up and to the right in a linear fashion. So we'll say that's linear positive. And the next one, you can see the information kind of starts out low and then kind of goes high and then back down. So I'm going to say that would be quadratic negative because it opens downward. The next one, you can see the trend is going to the right and up. That looks like exponential growth. Then we have, it looks like another linear going down. That would be negative. And then the last one would be our exponential decay. At this point, I would go ahead and take a screenshot or pause the video so that you can make notations of what's going on here and you can use in the future. So here's everyone's favorite question. Why do we do this? Earlier on the previous slide, we talked about scatter plots. Those help us or help mathematicians see trends more quickly. They're used in the real world to form what's called a regression analysis, which is just another way to make sense of what's going on in the real world and how it impacts us on a daily basis. The process in which they create the analysis is a regression process used to determine with confidence which factors matter more, which ones don't, how they can be ignored, or how they influence each other. Okay, so let's get started with some examples of how we're going to find different regressions, mainly the three that we've discussed today. I'm going to show you three different regressions along with three different methods to find them. So the first one is going to be with our TI-84 calculator. But first, let's go ahead and take the table data and put it on our graph. So the first coordinate, 0, 36, you notice my y-axis only goes to 34, so at the very top we'll make our 36 and put a point. So here's our point. Then we have 118, so 118. Then 2, 9, 3 and 4.5, 5 and 1.125, which is pretty close to around in here. Now you can start seeing a trend. The data is going down and to the right. So this is mimicking an exponential decay, and that's the regression that we're going to find in our calculator. So next, let's plug this information into our TI-84 calculator, and so you'll know how to get the regression that way. So make sure you make any notes that you need to on a separate sheet of paper. Make sure your stat plots are turned on. Second, y equals, enter. Next, you're going to go ahead and enter your data under Stat Edit. After the table data has been completely entered, make sure you go into Windows so that you can adjust to see all your data. Here you can see I did my Y max at 40 and my Y scale at 4. Go ahead and hit the graph button so you can see your scatter plot you created with the data from the table. Now go ahead and create the regression by going to Stat, Calculate, go down to 0 for a exponential regression. Hit Enter, and then you're going to go down all the way to Calculate. Hit Enter again. This is now going to give us our exponential regression equation that we need. Okay, so now that we have our regression, let's go ahead and write down for our final answer. We have y equals 36 times 0.5 to the x power. Don't forget that we can write the same regression as f of x equals 36 times 0.5 to the x power. Here we are on example B. The first thing I'm going to do is go ahead and take the data from my table and put it down onto the graph. My first point is 0, -5, then 1, -2, 2, 1, 3, 4, 4, 7, 5, 10. It looks like my data is going or is trending in a positive direction and looks pretty linear. I'm going to go ahead and put a line of best fit. So I now know that I'm looking for a linear equation, so I need to perform a linear regression on Desmos. All right, we're going to do regression today via Desmos. This is available on your computer as well. So to get started, I'm going to go to the very top left-hand corner. I'm going to hit the plus button and go down to Table. Here, I'm going to enter my data points that have been given to me. And in my X column, I'm going to put 0, 1, 2, all the way to 5. And then for my output, I'm going to do -5, -2, 1, 4, 7, and 10. To the right, you'll notice right away that you see some data points being plotted. To see all of these, because it doesn't look like the screen's large enough, I'm going to zoom out by pinching my fingers together on the screen, and then it gives you a really good indication of what it looks like. From here, you can see, based on the data, that it looks like it's going in a very linear direction, which is great. So that means we're probably going to do a linear regression based on what we know from our parent functions. Okay, so on my next line, line 2, I'm going to go ahead and put our regression equation for a linear function. We know that linear functions are y equals mx plus b, so we're going to follow that same rule. Now to do it in Desmos, you're going to have to make sure you do y1, because that's where our totals are coming from. And then instead of equals, you're going to do an approximation. If you don't know where that is on your keyboard, you can use the one that Desmos provides for you. Just make sure you click on the ABC button, go across the bottom, just past the braces on the right, and hit the little approximation. Now I'm going to go ahead and close my keyboard out of the way. Then I'm going to do m for our slope, and then I'm going to do x. Now x is your input values, but I also, if you'll notice at the top, it has x1. So I'm going to put a 1 here as well. Then I'm going to do our plus b. And there you go. Now you have the information or our parameters down here on the bottom. These two values, your m is going to be your slope of 3 and your y-intercept of -5. So this is a strong correlation. It looks like a great line of best fit. Now that we have all of our information together, let's go ahead and write our function notation for this particular regression. So we're going to start with f of x, which is the same as y, equals 3x minus 5, and that's what you would put for your answer. All right, so here we are with our last example, C. We're going to do this regression as well. We're going to first take our table data and put it on our graph. Our first coordinate is 0, 3, 1, 1, 2, 3, 3, 12, 4, 27, and 5, 48. Now looking at the data points that we've put on here, you can see that from left to right as you read it on the graph, the data points are going down and then it curves back up. I'm going to say that this is probably going to be a quadratic. It looks like a partial parabola. If I connect the dots, try to get like a line of best fit, you can see where it goes down and then back up. So the final part of this is getting the regression. So we're going to do a quadratic regression using the regression calculator that you can access online. The link to access the calculator, the regression calculator online, is available through a link on your worksheet through Moodle. So at the very beginning, we're going to go ahead and enter our data that I provided for you on this page as well. On this one, you're going to do your inputs and outputs for each one as you tab over. So I'm going to go ahead and do 0, 3, 1, 1, 2, 3, 3, 12, 4, 27, 5, 48. So that's all my data points. Once I've gotten to that, I'm going to go up to my main menu up here on the top left. And it says Edit List. I'm going to do the drop down menu, and then I'm going to click on Calculator menu. Hit that, and then it shows a sub menu that you can see here, and another drop down. So I'm going to go down. And this one's going to be a quadratic regression. So I'm going to click on this, and then I'm going to hit calculate. Okay, so here's the results of our calculations. If you'll notice under the y equals ax squared plus bx plus c, that's your standard form of a quadratic. Down below, it gives you what each variable stands for, your a, b, and c. Depending upon what your teacher's requesting of you, you may have to round to the nearest whole number, 2 decimal places, or 3 decimal places. It's really up to what they're asking you. I'm going to give you an example of writing it with whole numbers and 2 decimal places. So the first function that we're going to write for our regression, the proper function is going to be f of x equals 3x squared minus 6x plus 3. That's rounded to the whole number. Or if they ask you to round it to 2 decimal places, we would have f of x equals 2.98x squared minus 6x plus 3.321. And that would be your answer. The last part of our notes is predictions. Let's look at some data. We're going to make some predictions and answer some questions. So let's read the information. It says, according to the Center for Disease Control, the CDC, the number of AIDS cases among people aged 21 or younger in the U.S. is finally starting to decline after seeing years of increase. So from here, I'm going to take the table data. It shows us in years as far as our input, and then our output is in quantities of number of AIDS cases. Now, when you're putting years in a table or in your calculator, you cannot type in years as a number. That is not how it works. If you'll notice down below on the table, there is some notation that says years since 2004. That's going to tell us that 2004 is going to equal 0. So above my table, I'm going to put 0. And then for every year after that, I'm going to just put 1. It looks like it's counting by ones. So the years are going up by increments of 1. I'm going to also go up by 1. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. It's quite helpful if you write those numbers at the top. It just kind of makes you not forget that those are your new X values. So the first thing it tells us to do is create a scatter plot. So let's do that next. So the first coordinate would be 0, 8,800, or at least close to that. So we're going to be close to 9, so right in here. Then 1 is around 17 and a half. So 15, 16, 17 and a half. Then 2 would be 25,000. We'll put 1 here. And then 3, it was going to be close to 31. So 30, 31 here. 4 is around the 35,000, a little above a 35,000 mark. So 35 and a half, close to it. Then 5 is close to 39. So we'll try to get as close as we can to these values. I know the pen is not the best. And then 6 is 40, a little over 40. Then 7 is 41 and a half. Then 8 it looks like the data is dropping back down. This one's now at 40,000 or close to right below 40,000. And then 9 is right below 38,000. So as you can see, there's the trend, the data is going up, and then it's kind of at a peak, and then it's starting to come back down. So this to me looks similar to a quadratic quadratic function. So that means that we're going to need to do a quadratic regression. So let's go ahead and answer the questions. We did the scatter plot, check. Which model does the scatter plot resemble the most? I'm going to go with quadratic. It's definitely not linear or exponential. And then it says determine the regression equation from your answer to part 2. So we'll do that next. All right, so for this last part of the question number 3 and number 4, I'm just going to share with you the information, how I put it in the calculator rather quickly. You can always go back and watch the other video that explains more in depth on how to enter all of the information in the calculator. And then we're going to come up with a regression as well as predict how many cases we'll have in the year 2020. So let me get you started on the calculator. All right, so when we go to our calculator, hit stat edit. I'm going to go ahead and I already have my data entered. Stat calculate next. That's where I'm going to do my quadratic regression. Go to 5, hit enter. And then I'm going to go down to store regression equation. I'm going to arrow down there. I'm going to hit the vars button on my calculator. I'm going to arrow to the right, hit enter, and then enter again. And then I'm going to arrow down to calculate. This is going to store my function equation in y equals for me. So here's my regression. You can write that down. We'll do that in a second. And now I'm going to hit graph so that you can get a view of what's happening on the calculator. You can now see the data points from the regression. You can also see the y equals equation once I stored it into y equals, and you can see the trend, how it made the parabola. To predict what we're going to do in 2020, we need to continue our x values down to 16 because that would be in an additional 7 years. And here you can see that it's a negative value, meaning based on the trend that we should be seeing no more cases by then.